My name is Libranner Santos, and this is the name of the talk. First of all, good afternoon, everybody, and I'm really glad there are so many people interested in knowing about auto layout. This is me, Libranner Santos, software engineer. I work as an author and tech editor for the guys at Ray Wenderlich. Probably most of you have heard about it over the internet. Also, I consider myself a Swift and iOS enthusiast. I've been programming like backend development using Swift, but that's for another talk. And you can follow me pretty much everywhere just using my name. Yeah, is that weird? How many of you have used auto layout in day-to-day work? Nice. Yes. I was a little worried because I was seeing the guys competing in the mobile battle, and none of them use auto layout, never. Just use like frame and stuff, and come on, guys, that's a stack view, and everything will be done real fast. So this is my outline. First, we will start talking about some important concepts that we need to know. We will spend a significant amount of time talking about debugging. We will use an app that we will be working here right now, and we will solve a couple bugs. Also, we'll talk about the types of errors you can find in some tools and techniques you can use when you're working with auto layout. First, I want to spend a couple minutes talking about this question right here: what to use, code versus Swift versus interface builder. And at the last part of the talk, we will be giving you some tips and tricks that you can use while you work with auto layout to make your life easier. But last, sum it up, and then a section where to go from here. So the auto layout engine, intrinsic content size on alignment rectangles and render loop. Those are the three important concepts we will be discussing here. So this graphic on my left is what you call, it has everything. It has the engine, which is the green square at the top, which is the auto layout engine. And this window refers to the screen you normally see when you're running an iOS application. The views, you can have as many views as you want. And the constraints, which are just like equations that represent a relationship between one or more views. So the engine is what makes auto layout work. It manages all the calculations. It's also, and this is really important, it also acts as a dependency tracker. So that's why you shouldn't worry too much about your constraints, because he knows what he has to change when you rotate your device. He's pretty smart. And we will be talking a little bit more about that in the late in this talk. So the auto layout engine takes the constraints you create and infers the size and position of every view. The intrinsic content size and alignment rectangles. This is really important because, for example, if you have worked with UI using iOS, intrinsic content size is something that do a lot of work for you. For example, when you use labels and buttons, you normally doesn't have to set a height because intrinsic content size just calculated using the font size. And alignment rectangles, it's something pretty curious because if you see the image on the left, that's a label that has a shadow. But when you work with auto layout, if you want to position that label, it won't take into account the shadow. You just take account like the label and the letters. So that's really important to have to keep in mind when you're working with auto layout. And probably the most important concept in this slide is the render loop. This is pretty similar to layout subviews. It has like three methods: update constraints, set needs, update constraints, and it has like the naming is pretty similar to what you see in layout subviews. And there's something you have to know. The render loop runs probably 120 times per second. So whatever you do on the update constraints will probably run 120 times sometimes. So you have to be careful on what you put in there, and we'll be talking a little bit more about that when we talk about churning, which is an issue you can see while working with auto layout. Another thing is that the render loop runs from the last view in the view hierarchy to the window, and layout subview runs in the different direction. from the window to the last view in the view hierarchy. And then the view just gets displayed using the draw methods and all this stuff. So debugging. As per Apple documentation, we have 3 types of errors. With our logical errors, there's, maybe you use some run number in a constant, or you set a constraint without using the proper anchor, just like everything, it happens to the best of us. And unsatisfiable constraint, that refers to when you have too much constraints. And our layout doesn't know what to do, doesn't know how to give you the solution you want. And ambiguous constraints is when there are not enough, or there are more than one possible solution for the constraints you set. This is usually can be solved using content hogging and content compression resistance, but in some cases it's not enough. Normally, for example, when you work with a lot of labels, if you want one label that can grow a lot, you set priorities, but as we will talk later, priorities are one of the most expensive things for the layout engine, so be careful how you use it. And another one I want to add is performance. When we work with our layout, we normally don't take this too much into account, but there's a lot of powers in our hands, and even small things that the one I will show you when I explain you about the feedback loop can be like, we can literally just crash the app with one line. So through this talk, we will be working with this app, which is a simple memory game. We show a sequence to the user, and he has to tap every square in the same order to win. If you miss, the games just stop and tell you your points and the time you spend playing. So let's do that. But first, I would like to take a couple minutes to talk about this. This is visual format language. Have you ever worked with visual format language? Does anybody know what that is? Nice. So people tend to not use it, even though Apple recommended. But Apple recommend a lot of stuff. Apple recommend interface builder too, and who can argue about that? And you have to know this especially because normally when you have issues with auto layout, the errors display in this format. And you won't understand anything if you don't even know the basics about this. For example, if you see this blue line on my left, we indicate the first letter is the orientation. In this case, it's horizontal. And what we are telling this is we're working on the horizontal axis. So all the values you put here will be, for example, when you say icon label parentheses 1 to 0, we're saying that that label will have a width of 120. And the at symbol means priority. That's the priority we're giving it to that constraint. And it's pretty easy to understand if you give it a try. And it's necessary because we will see later in the slide, you can understand all the logs if you don't know anything about visual format language. Also, you can do everything you can do with anchors or with interface builder using visual format language. So let's see this. What we'll do right now is a demo. So let's go. Sorry. So let's run the app. As you can see, this doesn't look like the app we just showed in the slide, right? So we have our game board right here. We don't have a header, even though, as what I will show you right now, it's in the storyboard. The header is right here. But as you can see, we have all these red lines. Also, another thing you can see right away is we have this log right here telling us that something went wrong. And a little thing I really like to do is, if the app have this kind of error, I don't want it to run. If I'm in debugging session, if I'm debugging my app, so I will go here. I will just go here and create this breakpoint a symbolic breakpoint. You create a symbolic breakpoint just going to the left bottom corner and tapping here, symbolic breakpoint. So you use this really long name for a constant, thing.jptc, and we just press enter. So right now it's disabled. I'm going to enable it and run the app again. So as you can see, I'm getting a crash right now, and it's telling me pretty much the same thing I was seeing before. So what's good about this is the app won't be able to run, and when you have like a big app without a lot of stuff, a lot of logging, you can easily lose these logs and don't know there is anything wrong with your app. There is something wrong with your app. So what we'll do right now, we'll read this log, and as you can see here, there is some visual format language telling you some constraints. In this case, is a constraint related to the view safe area layout guide. And one interesting part is this right here. Our layout engine is smart enough to try to solve it by itself. And what it does is when you find an ambiguous layout, as I told you before, you have too many constraints and he will try to solve it for you. He just removes one. But you can never rely on this because he just takes one randomly. There is no logic in that. So right now, what he's doing is he's removing this constraint that indicates the height on my header view. And that's what's causing that I can see my header view when I run the app. So what I'll do, I'll go here, and I will check. Also, another thing you have to do is you have to actually know what constraints is causing the problem. So if we analyze this, we don't have to remove our height, and we're indicating that the header should be aligned to the top. So we have a problem in the vertical axis because he's trying to remove the height. If the problem was in the horizontal axis, he will remove the width or something like that. So we know where the problem is. It's in the vertical axis. So what we'll do right now is, if you check here, we are indicating that it should have a space from the bottom, and we don't need that because you're setting the height. So I'll just remove this constraint, pressing function and delete, and as you can see, we don't have red lines now, so I will run the app. Okay, now we have a header on the top, but we still have this board here, just not in the correct position. Let's check what is happening over there. So this is the function that creates the board, and as you can see, it's not the best code. What we're doing right now, we are creating every button and creating the constraints based in the previous button that we created. This is just bad code, and it serves for a purpose that I wanted to explain right now. I will just, you can have a look, but I will just delete this. Okay. Go right here. And insert my improved version. So what I'm doing right here is I create a stack view to contain all the game board, and also I create stack views for each row of the board. You can argue that there are probably fancy ways to do this, but I really wanted to explain that stack view is probably the more useful control you can rely on while working without a layout, because it handles a lot of stuff. For example, if you want to hide some control, if you want to, if you want to have an interface that works in landscape and portrait mode, stack view handles pretty much all of that for you. And for example, when you hide a control that is inside a stack view, it handles the spacing automatically. And what we're doing right here, we're creating the border, and then we're creating every row. And see if you run that, let's run it. You'll see that we are almost there. Right now, it's aligned at the center. And also another concept I wanted to explain to you is something really simple that Apple have been doing all this time. For example, when you work with a UI table view, Normally, when you create custom cells, you don't create the constraints directly to the UI table view cell, even though you can do it. You create constraints using the content view. And you should do that too when you create constraints view. You should create containers and rely on that for creating your constraints. Because, for example, if you use stack views, stack views are not a real view. You can change the background of a stack view. It has to be inside of a container. So we created this container right here, where we assign the stack view to the container, to the gray one. And what is happening right now is, as you can see, we are not getting any error. That's just something fun there. We're not getting any error, but the layout is not looking that good. So let's use another tool. It's called view debugging. It's a way to see the view hierarchy. And as you can see here on the left, we have a lot of issues. If you put the mouse over this icon right here, it's telling you that the height is ambiguous. So there's something wrong with the distribution of our stack view. Also, you can go here and see a more simple visualization of all the issues we have. So if we go here and change the distribution to fill equally, because what it's doing right now is just filling it any way it can, but we need to be equal because we're working with the squares. So if I run it again, it's looking way better now. But what if I told you that even though it looks good right now, we still have some issues that we haven't seen. And for that, I will show you another tool you can use. I will pause the program and run this command right here. And this command right here is the auto layout trace. This is part of some UI view methods you have access while working with auto layout. This one, as you can see, have an underscore at the beginning, so you won't be able to write some code using this method. But you can run it while running LLDB, which is the compiler for iOS. So if I press enter, you'll see something similar that what you see when you're working with the view hierarchy we just saw before. But if I press Command F and look for ambiguous, here it's telling me that there is something wrong with a UI label. And the advantage of this is, for me, it's more easy to find something using view hierarchy. But if the interface is like really complicated, maybe using the 3D model could be tricky and you can find what you're looking for. But if you're looking, for example, for an ambiguous layout issue and you use this command, it's pretty easy to find it. So let's go. As it's telling us that that label is inside a view called timer view. So we'll go and check on that view. So it's the only label we have in this view, and it's the one responsible for showing the timer up the top. So if we go to the update constraints method, can anyone here tell me what is wrong with that label? Why is telling us that it has ambiguous position? One. It's pretty easy. So what's happening is that we are not indicating a position for the horizontal axis. We're just indicating the vertical position, which is y, at the center. So what we'll do is we'll just change this and this. Let's run it again. If I press pause here and run the command, we'll see we don't have any errors now. Pretty cool, huh? Also, another thing I wanted to show you real quick is with the view hierarchy, you have a lot of options. You have this awesome 3D model, and also you can press any object, any view, and have more information about that view. That's pretty cool. But sometimes when you have a really complicated UI, it's not enough. Okay. So as you saw here in the timer view and the update constraints method, what we're doing right here is pretty crazy because we are deactivating all the constraints in the right, these two constraints, and then removing them. And as I told you before, this update constraints method runs every time you need to change something in your view. So what we're doing here is pretty much, so you can see it in thinking about performance, what we're doing here is like removing all the views and creating it again. It's not that bad, but it's similar if we're talking about constraints. So this is something called churning. And I saw this talk from Apple when they said this is the most common issue in client code. And it's pretty easy to solve. So what we'll do right now, I will just remove this. Oh, sorry. And add this method. And all I did was checking that the label constraints array is empty. So I do this, and if it's empty, I then create all the constraints and add it to the specific UI view. And also activate it. So if we run it again, you'll see that everything is working just fine. Let's play it. So what is a sequence gate is indicating what square I have to press. And let's say I want to see the history. I want to lose on purpose. Just press here. I lost. It's telling me I got 2 points. If I press the history here, the app just froze. So what is happening? You're seeing here we are using 90% of the CPU. So there's something really wrong. But the app is not crashing. It's not telling us anything. So what's wrong? For this, I will show you another tool you can use, which is the UI view layout feedback loop debugging threshold. What this does is, this number, in this case is 100. You can put any number between 50 and 100. If something with the render loop runs more than that number you indicate over there, it will just, in the left, it will show you some useful information so you can solve it. Also, the app will crash. So let's try this again. So if I press play, I will just lose on purpose and press this here. Now the app is not frozen and it's telling us this really big log. That's something really bad with the feedback loop because the logs are always really big, and there is no easy way to find what is wrong. You just have to look through it. But I will give you a tip right now that can help you to find the issue kind of fast. So what we'll do is I just press Command F right here and type dirty. So usually when you have this kind of issues and you see this test right here, upstream layouts dirty, it will tell you what's wrong. But it's not always the case. Normally you just have to dig through this whole log and see what's wrong with our layout. So it's telling us that there's something wrong with our setNeedsLayout method, and it's related to the table view. So let's go to that controller, which is right here, and see where we're calling setNeedsLayout. What is happening right here is we're calling setNeedsLayout inside view did layout subviews, and this is creating a loop. So every time we finish doing the layout, we're calling it again and again and again and again and again, and it never ends. So if I just remove this and run the app again, also you can see here that it's telling us that we have this option activated. You can just remove it anytime we want. But if I play, let's just do something. I will lose some purpose, and now it's working. Now it's showing us our score. That's really good. Let's go. So first, in the demo, we saw something about understanding the logs, what tools you need, pixel format language, and how the symbolic breakpoints can help us know when there's something wrong without a layout. Also, we saw the view debugging and the view hierarchy, which is an awesome tool you can use to check, not only to solve auto layout issues, to see if there's anything wrong with your UI. Also, we talk about churning, with as I told you before, is one of the most common issues you find while working with auto layout. And also, we saw a little bit about the auto layout feedback loop. So this is a question I pretty much every time people ask me. Between code, using zip files, and using interface builder, where will be the choice? And the answer is, as always, it depends. But for me, it depends mainly in three things. Your team, what's the experience of your team? Because, for example, working without a layout is not easy it's not that easy if you just do code. Because you don't have like the automatic feedback you have while working with interface builder. And you have to write all this code and then run and then change things and then run again. So if you have people that doesn't have that experience, maybe it's not the best choice going for code. Also the complexity of your UI, because let's say if you're doing something like really, really custom, maybe code is the best option. But interface building can get a little messy. Also, if you ever work in a team that have been working in the same storyboard, you have like a lot of issues with merge conflicts if you use GitHub or any other version control. Also, how important is reusability? And this is it sounds kind of bad, but you have to be honest with yourself. Us as programmer, sometimes thinks that everything has to be reusable and all this stuff. But if you're doing like a really small project, maybe you shouldn't think a lot about reusability. So the project is just a form that people have to enter some tests and just send it to a server. You don't have to create a lot of classes to create custom forms because you won't need it. And in that case, maybe interface builder is the best option. Zip files are really cool when you want reusability. For example, you want a really custom loading page that you want to use everywhere in your app. Maybe zip files is good for that. But I think most of the time, the experience of your team will give you the answer. Because, for example, most people when use code is because you can reuse a lot of things. For example, if you want to center a view inside another, you have to always write all the constraints, center X, center Y, unless you use something like a snap keep that we will mention in a moment. And that can be a little tedious. But you have to first talk this with your team and see what is the best option. So, some tips and tricks. First, we will see this awesome page, which is called WTF Auto Layout. Yeah. 1 second. And what I did here is I just pasted the log we saw before. And if I press this button right here, you'll see this awesome view. If you are so lazy that you don't want to learn anything about visual format language, you can use this page, and it pretty much tell you what you saw in the log, but in a more visual way. It's pretty cool. So, another thing is, apart from auto layout traits, there are another set of methods you can use while working with auto layout, which has ambiguous layout. It returns true if there is something wrong with your UI view. Also, there is constraints affecting layout. This method receives a parameter, which is the axis, For example, if you want to see what countries affect the horizontal axis, you just have to pass that value as a parameter. And also, there is exercise ambiguity layout, which creates this scenario when the app behaves like if there's something wrong, so you can see how to handle it in case anything goes wrong. So another tip: be aware of your layout guys. In the past, when you want to create a spacing between views, normally one of the ways we're creating like these spacing views just for that. But now without a layout and a layout guide, so you don't have to do that. And be aware, apart from the save area layout that probably most of you know, there are layout guides that help you with readable content. Because, for example, if you have this label that has a lot of content, there's a layout that determine how many characters you can show per line. Because, for example, in the iPad, you don't see the same amount of characters you see in an iPhone in portrait mode. It handles all of that for you. So you have to be aware that that exists and you can use it. Also, use stack views. It's just the best thing for working with the auto layout and doing all kind of crazy stuff. Normally it takes time to see a whole user interface in this approach of doing everything with stack views, but it's worth it. Also use view containers. As I told you before, this can save you a lot of time, and it's always a good idea. For the interface builder, one tip is to use the preview window that probably most of you know. A second. If I go here and press this right here, I can see how my app will behave on different devices. So if I press add and just say, okay, tell me how it looks on the iPhone X or iPhone X, iPhone AX, or wherever, you can do it. Identify your constraints. Your future self will appreciate it. I will show you that after I finish this. But this is something really simple. You just have to go to the file inspector and put a name on your constraints. And that way, when something wrong happens, like it will probably do, you can see more information about what's really happening and not just these crazy numbers related to the UI view. You can see what view is causing the errors. You can even assign a name to the constraints, to the specific constraint, and just find a way to solve more fast and easy all the issues you can have without a layout. Another thing that I will show you is use resizable and scalable images when possible, and when possible, slide them up. So slicing is something that it comes with Xcode and is really useful when you have these images that can grow just part of it, and if you want part of it that stay fixed. For example, if you do a chat application and you have this bubble for the chat and you have the left side to stay fixed and just the right side to grow, you can do it with slicing. And don't forget, you can use IB inspectable and IB designable. This allows you to create custom views and see how they will behave while using an interface builder. It's something that I have some hard time working with it because sometimes the interface builder is not so good handle it, and sometimes this works, sometimes that. But it's a pretty cool tool to have in mind. Another tips about performance: don't create layouts that try to accomplish a lot of scenarios. Remember, for example, if you're using storyboards, you can have as many storyboards you want. If you're using custom views, you can just create all the custom views you want. When you try to accomplish a lot of scenarios with one layout, things will get messy. And when the issues come, you won't know how to solve it. Inequalities, some people think, because they are kind of not normal equations, let's say, that are that they aren't cheap, but the auto layout engine is one of the cheapest things you can do. Also, I don't know if you know, guys, but the auto layout engine is based in the algorithm called Casori. Also, I think the constraint layout for Android is based on that too. Which basically is just a system of equations that it creates a system of equations, it finds a solution, and then it runs a simplification process just to try to give you the answers. And one thing it handles just like super easy is these inequalities. Constraints constants, as you know, you can normally create outlets for constraints, but you can create outlets for constants. And that's because the auto layout engine, as a dependency tracker, handles these changes more easily than changing the whole constraint. Try to use properties wisely, because that's the most expensive thing for the engine, handling properties. So one thing I can recommend you is, by default, you have a priority of 1,000. If you can just put like 900 on 999, it can help you, because auto layout will know what constraint it can break when something was wrong. So another thing about performance is avoid churning. As I showed you before, if you can find a way to not have to remove all the constraints and adding them back again, go for it. And when possible, if you have to hide views, or just use a stack view. And if you hide them, it will do pretty much all the work for you. Also, another thing is overriding the intrinsic content size property can help you with performance. As you know, the engine calculates sometimes all the sizes, the intrinsic content size. But if you know that some layout will have exact size, just override this property and you will save a lot of processing time. This is the other side of the coin, the system layout size fitting. This is really expensive, and it's something that a lot of people tend to use. For example, when you want to calculate the size of a label, try not to use it. Most of the time, using constraints, you can accomplish exactly that without having to do some calculations and all this stuff. So I will go and show you real quick what I was talking about, identifiers, because to be honest, I've never seen anyone using this option. This is the readable layout guide I was talking to you before. You just have to set this and do some tricks, some tuning, and you will have like layouts that respect this standard that Apple has for the number of characters you have per line. And the identifier, you just have to go here and indicate whatever name you want. Also, you can do it for your views, and you will have like really a lot of useful information while dealing with issues. So summing it up, here we talk a lot of interesting stuff while working with auto layout. I expect, guys, you learn something from this, and you have more confidence while dealing with these kind of issues. For me, I have like at least 4 or 5 years working with this kind of stuff, and it always appears something weird or something you're not expecting with your layouts, but I think it's worth it. Most people think that using frame-based layout like sprint and strut and all this kind of stuff is better for performance, but let's say we can argue that. And normally, unless you're working with collection views or you have this really complicated UI, it's better to just use auto layout. Another thing you have to know is the guys at Apple, like every WWDC, make improvement to the auto layout because they are betting strong for this. So where to go from here? If you want to learn more about auto layout, you can just take these awesome tutorials from Ray Wenderlich. That's a link for if you want to learn a little bit more about visual format language. Also, there's this talk about best practices, really nice. And if you want to take a look, a more detailed explanation about high performance auto layout, there is this talk from last year, really awesome for the guys at Apple. in WWDC. So that's all for me, guys, and I hope I wrote that the correct way, so don't take it over.
Thank you very much, Libranner, for your talk. So we have time for questions.
Thank you very much for the talk. Very interesting. Basically, you never know enough the topic. Yeah. My question is about removing constraints. Pretty much a common scenario in my current project is to making UI view animations based on changing constraints. Assuming we are removing or hiding a view, then another view constraints becoming inactive or removed because of they were relating on that view. So, and we need to add another constraints, let's say, and then we call UI view animate layout if needed, something like that. And so this animation occurs. And it's based on constraints changing. So my question is, why is that bad? Why is bad to removing constraints? So it was on one of the last slides in your presentation.
No, well, when I use it, the next time I just remove that line because that is really bad. If you have to do it, if you have to remove it, go for it. But it's like the last option you have to use. If you can, in your case, do something like, I don't know how complex the animation is, but if you can rely on constants, if you can, normally with animation you tend to remove the view from the view hierarchy. I don't know if you guys, but I will say to you that if you can avoid removing constraints, do it, because it's pretty much in the outer layout engine, it's pretty much like removing the view and adding it again. It's not the same, but it's like a similar for what we are doing right now if we are removing all the constraints. Maybe, I don't know, I'll have to see like what you're trying to accomplish to have a better idea, but I would recommend to use, if you can use auto layout to handle like hiding views and the spacing and all that stuff, I'll go for it. But yeah, I'll need to see the code to give you a better suggestion.
Thank you very much.
One more question.
Hi, thanks for the talk. It was interesting. I think you mentioned SnapKit in your talk, but what is your general attitude to different other approaches to the, well, actually, it's not even to the constraints, to making layouts for iOS. I'm not talking about frames, I'm talking about different frameworks we have. Some of them gives you better syntax, some of them puts some calculation into background thread instead of main thread. So what do you think about all these things?
Okay, first of all, good news for you. We're working right now in an article based on SnapKit. It will come out probably next week. Also, I didn't want to put it on my presentation because most of the time I'm against using libraries if you can do it yourself. But SnapKit is pretty cool. And the main feature I think is you avoid having errors like using translate, auto resizing max equals true, it does that for you. You can use chaining too. But in terms of performance, I don't think you gain much because all that it does is creating this awesome DSL for you to do the same you can do using anchors or using visual format language. About what you said about putting calculations in the background thread, I don't say I'm against that, but believe me, the guys at Apple do this amazing job with the auto layout engine for you to try to do crazy stuff. But I've worked with this guy one time, and they do like really crazy stuff with the collection view. And for that specific scenario, using frames was a lot faster. I have to admit that. And I will go for it, but it has to be really crazy stuff right now. Because, for example, they show this app running a collection view with a lot of stuff from iOS 10, iOS 11, and then the same app running iOS 12, and it was like smooth because they are working on it like pretty much all the time. All WWDC you see something different about our layout. And that's it. Me myself, I tend to not use libraries in like Alamo Fire. I use it a lot, but not much like that. I always do my layouts by code using anchors and all the stuff.
And we have time for one last question. Yes.
Making count.
Thanks for a great talk. You mentioned stack views a lot and recommended to use them. But I have one question. What about some dynamic UI? For example, table view after sizing cells. Isn't using stack views is too expensive for dynamic UI?
Not really. But for example, you can't, well, if you're crazy enough, you can do it, but you can't do what you do with a UI table view with a US stack view, you know? There are different scenarios for this kind of stuff. And you mentioned that table view, the row height, like the way it calculates the content size, that can be expensive too, because, you know, there's a lot of things going on in the back. But it's not one or the other. Even you can put stack views, and I've done this, you can put the stack views inside a UI table view, a table view cell, and handle like a lot of stuff if you have like a lot of information there. But maybe if you get to that point, you can just use a collection view, which is like a more, let's say, ideal control for the UI. Like, it's more ideal for that scenario. But I don't know, answering you, I don't think it's one or the other. You can use UI table view, but what I recommend is, for example, and I will tell you, in the mobile ladder here, they put this this UI, a login page, and you can do that with stack viewing just like, I don't know, 20 lines or something like that, and you don't have to worry about the spacing between the views, and if the user rotates the device. For those cases, there's nothing better than stack views, you know, in terms of time and getting something like done real good. But table views are another story, you know. It's different scenarios.
Thank you.